Fluid Power Systems, Part 3 of 3. Types of air pressure. Atmospheric pressure. Atmospheric pressure is generated by the weight of the air above you. Gauge pressure. The value that a pressure gauge identifies is referred to as gauge pressure, which should not be confused with atmospheric pressure. Zero gauge pressure starts at atmospheric pressure. Absolute pressure. Absolute pressure is based on the concept of a perfect vacuum or absolute zero pressure point, and is defined as the total pressure exerted on a system, including atmospheric pressure. Absolute temperature. Scientists and engineers use an absolute temperature scale, the Kelvin scale, to predict changes in a gas's physical properties. Temperature is a measure of the movement of molecules. Absolute zero, or 0 Kelvin, is the temperature at which all molecular movement stops. There are no negative values on the Kelvin scale. And then there you have our two formulas to convert from Celsius to Kelvin and from Fahrenheit to Kelvin. Perfect gas laws. Charles' law, Gay-Lussac's law, and Boyle's law are defined when one of the three variables are kept constant. Boyle's law. When a confined gas's temperature is kept constant, the resulting mathematical relationship between volume, absolute pressure, and absolute temperature is known as Boyle's law. Boyle's law states that a gas's absolute pressure is inversely proportional to its volume, provided its temperature remains constant. So here we have P1 V1 equals P2 V2. This is Boyle's law. The first pressure times the first volume is equal to the second pressure times the second volume. Charles' law. When a gas's pressure is kept constant, the resulting mathematical relationship between volume, pressure, and temperature is known as Charles' law. Charles' law states that the volume of a confined gas is proportional to its absolute temperature, provided its pressure remains constant. So we have V1 over T1 equals V2 over T2, our first volume, our second volume, our first temperature in Kelvin, and our second temperature in Kelvin. Gay-Lussac's law. When a gas's volume is kept constant, the resulting relationship between volume, pressure, and temperature is known as Gay-Lussac's law. The absolute pressure of a confined gas is proportional to its absolute temperature, provided the gas's volume remains constant. P1 over T1 equals P2 over T2, first pressure, first temperature, second temperature. In your engineering notebook, answer the following questions. How is a hydraulic system different from a pneumatic system, and what advantages does one have over the other? What do hydraulic and pneumatic systems have in common? What is the difference between hydrostatics and hydrodynamics? What is the difference between a fluid's flow rate and its flow velocity? What are applications of Bernoulli's principle? Why are the standard Fahrenheit and Celsius temperature scales inappropriate for calculating the physical properties of gases confined pneumatic systems? How do liquids and gases differ with respect to compressibility? Identify 3 disadvantages of hydraulic systems and 3 disadvantages of pneumatic systems. And what are standards and why do engineers develop them?